perfect, but it doesn't work in my case, I believe. Thank you, Arthur. It is really a pleasure to be here. And I'm not sure if this has been said. Really shout out to the Zabbix team. You've put a great conference together at a great location and with a really large audience. In fact, let me take a picture, a selfie for my daughter. Wow. She's going to think I'm a rock star. Until she hears the talk, the recording, and then she'll be like, what was that? Why are you punishing so many people? It's boring as hell. You know, before this presentation, I received a checklist from the Zabbix presenter team, and they said, start with a joke. And I'm trying really hard. They said, it keeps the audience engaged. So are you engaged? Perfect. So my name is Birol. I am the co-founder and CEO of iAlert. iAlert is a company based in Germany. We're a SaaS company for incident response. And as of today, we cover everything around incident response. This includes alerting, on-call management, status pages, and incoming phone call routing. And we have been an integration partner with Zabbix for quite some time. Like 2016 was the first integration partnership. And I think it has been among our first 10 integrations whatsoever. And we have over 100 integrations. And one thing I can definitely confirm, what Alexei said yesterday, is that the Zabbix community is all over the world. So even among our customers, like all the customers who use iAlert in combination with Zabbix, they are all over the place. So that's really nice to see. We're used by DevOps teams, SRE teams, ITOps teams to reduce response time. So the single goal of using iAlert is helping teams respond faster to incidents and reduce MTTR. And then we serve as the central dispatcher for critical events in a company and route those critical events to the right people and do things like calling you at 3 a.m. in the morning, sending you a push notification. If you don't pick up, call your colleagues, so on and so forth. And we are very proud to serve small and large companies alike. So companies like Rewe, one of the largest grocery retailers in Europe, use iAlert for incident response. Or IKEA, the largest furniture manufacturer and retailer, use iAlert among 3 continents for incident response. I'd like to set the stage by showing you the results one of our customers was able to achieve through intelligent alert grouping. This is what we're going to talk about right now. So another AI talk. So within 2 weeks after enabling intelligent alert grouping, that particular customer was able to reduce 93% of alert volume and was able to save over 4 hours in response time. And as you know, every minute in saved response time is a minute in an improved MTTR. And every minute in MTTR improvement leads to service uptime, which is one of the most important KPIs for ITOps teams. And this is pretty much in line with what Alexei said yesterday, in line with Zabbix's mission to help companies deliver flawless services for a better world. What a powerful mission. So let me show you how you can achieve this too. So this talk will be somewhat technical, but not as technical as Wolfgang's AI talk yesterday. So no autoencoder deep neural networks with LSTM cells, long short-term memory whatsoever. But we'll talk about a few concepts, and I would like to walk you through a few concepts that are helpful to understand what I'm going to talk, how to reduce alert noise. Let's first set the, be on the same page what alert deduplication means, or what we mean by alert deduplication. Alert deduplication is the process of identifying multiple alerts that refer to the same underlying issue, and we group them into a single alert. So yes, this can be also things like root cause and symptoms, but also they're just plain duplicates, where you have multiple alerts that refer to the same issue. And the goal is to avoid being flooded with multiple things, avoid having to review multiple alerts and saving time, valuable time when you are in firefighting mode. And we're going to use a technique called embeddings similarity search for deduplication. Sounds clunky, right? But bear with me for a second, I'll walk you through the concepts. This technique uses vector embeddings. What are vector embeddings? Vector embeddings, it's a mathematical representation of data in a high-dimensional space where each point or vector represents a specific piece of data, such as a word, a sentence, a document, or in our case, an alert. And these vectors, they are like the closeness of these vectors to each other, they represent their semantic relationship. And this is the main advantage of this approach is we're not going to look at textual similarity of alerts, we're going to look at the semantics of these alerts and group them by their semantic similarity. And in fact, these vectors, they are everywhere in like AI and large language models. When you, for example, use ChatGPT, enter a prompt, your prompt will be turned into a series of numbers first and then sent to ChatGPT or to the large language model. But the question is, of course, like what's the algorithm behind turning data into a series of numbers? And this is where the magic comes in. We're going to use an embedding model. And these embedding models, they are a special type of machine learning model, a special type of pre-trained machine learning model that learns to represent a specific like, category of data. These could be images, these could be texts. And in our case, it's a general purpose model that was trained on a large and a variety set of data, including like common data like Wikipedia, but also technical data, for example, question and answer pairs from Stack Overflow. And this is not the large language model when you talk, for example, with ChatGPT that gives answers. It's just a special model that turns your input into these vectors. Again, an example, a sentence like this will be transformed into a series of potentially thousands of numbers, depending on the cardinality, on the dimension of the underlying model that is used. Okay, but how can we use this for embedding similarity search? How can we use this for alert deduplication? It's a three-step process. First, we pre-process the alerts. Then we turn these alerts into vectors. Then we apply our deduplication logic. So let me walk you through each step. In the first step, pre-processing involves normalization and cleaning. By normalizing, we mean like having a common format to represent alerts. For us, it's a given because we are a software platform and we like collect alerts from a variety of tools, and there's a common format. I think in the case of Zabbix, that's the case too. And then there's a cleaning process where we remove everything that is not relevant for the task at hand, for the task of deduplication. These are things like unique IDs. That's not relevant for deduplication, or timestamps, also not relevant for deduplication. Or if you represent your alerts in, for example, in JSON format, we also remove all these syntactic elements from this JSON document. This will not only like save you tokens, which like, as of today is still the primary cost driver in any LLM application. It will just reduce the alert to its essence, and we end up with a plain text alert. This plain text alert is then transformed into a vector using these embedding models. And these embedding models you can use, for example, one of those that are provided by OpenAI. They have an API just for text embeddings. You send something and you get vectors back. In our case, this wasn't an option because like event processing, think of it like stream processing, it's a very core part of our software, and we process on any given day like millions of events, and we don't want to rely on an external API for this critical process. Like even if the API is super fast, it's still a network call. Instead, we are hosting these embedding models on our own infrastructure, turning each alert into these vectors and store these vectors in a vector database. And the vector database really is optimized for storing vectors and also to perform queries on these vectors. And we'll see why that is important in a second. And now comes logic. So each alert is transformed into a vector. Then we perform a similarity search on the database. That means we have this vector. we ask the vector database, are there any other vectors that are close to this vector? So this, the search applies a distance metric, for example, like cosine similarity, and it returns a number between 0 and 1. 1 meaning they are very close to each other, 0 meaning they are very far away from each other. And far away means they're talking, like they're completely different things on a semantic level. And when we set a specific threshold, it is higher than the threshold that we have set, then we just group the new alert with the existing open alert. That's our deduplication logic, like fairly straightforward, right? And the advantages of this approach is that we're not relying on textual similarity. We're looking at this underlying semantics of the alerts. And this is achieved, again, through this text embedding model. It's a very flexible approach. You can like tune your threshold, and it's also very scalable. Like in our case, again, we're processing millions of events, and it works because everything is hosted on our data structure. It doesn't require those like API calls or hosting like a really large language model with where you can also like talk to the large language model. We're just using the specific part where we're turning numbers, text into vectors. Things that you have to consider, of course, choosing the right model. In our case, it's a general purpose model. It's an open source model. Of course, like finding the right threshold, and also asking for feedback when we have like grouped alerts that were incorrectly grouped or correctly grouped, using this information for fine-tuning. Okay, let me show you how this works in real life. And I was told that the Wi-Fi doesn't work, so is it still the case that the Wi-Fi doesn't work? Let me check. Okay, it doesn't, so let me connect with my hotspot. That works. Cool. I'm not dependent on your Wi-Fi. So here's what I'm going to show you. In the top, I have our alert interface, and in the bottom, like I don't have a running Zabbix instance, but I want to like simulate a few alerts. So I hope this works. It says I'm offline, but let me see. I think will it work? So the first alert says like coffee machine on floor 2 needs a caffeine boost maintenance. So that's an alert. Let's send it to our API. Did it work? Is this connected to the internet? Let me start Postman again. I think, unfortunately, it's not connected to the internet. But why? That's actually the most interesting part of this talk. But I believe if we're not back on track with the internet, we have to cancel the demo. I have a few minutes left. Let me try again. Is it worth trying to connect with the Zabbix network? Is it working again? You guys know? No? I do have a hotspot, but for some reason, like Postman thinks I am not connected to the internet, which I don't know, shouldn't be true. Yeah, that would be great because it's really the best part of the demo, of the talk. So that's the hotspot name. Pix, okay, and what's the password? Don't read it out loud. Yeah. It works. Yes. Thank you, guys. So, okay, let me quickly walk you through this live demo. So we have the first alert, of course. It's the first, that's why it's, and a new alert was created. Coffee machine on floor 2 is needs some maintenance. Now let's rephrase this alert and say, alert, coffee machine on floor 2 is taking a coffee break. So it's still similar, not the same. So let's send it. Now this second alert didn't create a new one. As you can see here, it was aggregated into our already existing alert. So that's an easy example. Let's move on. Let's try to be funny. No Java from the Java machine. Floor 2 coffee maker is down. Let's send that one to the API. So of course, Java refers to coffee, Java means coffee, and that's why it might relate it to the same alert. So as you can see here, now we're at 3. We still haven't created a new alert. It's still the same alert. Let's try a counter example. Let's assume the water cooler is down. On the same floor, floor 2, it's not the coffee machine, it's the water cooler. So we would expect that a new alert is created. As you can see, we have a new alert. And now, I know what you're thinking. My alerts are not about coffee machines or water coolers. My alerts are about CPU, hosts not being available, about hard disk drives. Let's try a more technical example. The hard drive is full. Because this is the first alert of this nature, a new alert is created. The hard drive is full. Now let's send another alert that says the storage capacity has reached the limit of 90%. And as you can see, there are no common words between the hard drive is full and the storage capacity has reached its limit of 90%. There's not a single word that's common except for the. So this one didn't create a new alert. It has aggregated the storage capacity has reached its limit of 90% into the existing alert. Now, okay, I think, you still might think my alerts are not phrased like these. This is natural language, there are complete sentences. My alerts are technical, they are cryptic. Let's try a few alerts, a few real alerts from Zabbix. These are alerts where we know there were instances of alert flooding. So there were, within a short period of time of 10 to 15 minutes, there were over 50 alerts created. And for this, I am going to, I have prepared a script from Postman that simulates these 50 alerts. But before I do this, let me go to the Zabbix alert source in iAlert and deactivate intelligent alert grouping. So intelligent alert grouping was deactivated, and let's run this collection. So it's going to, yeah, Wi-Fi. What's here? Okay, let's do some quick live debugging. Select the file. Okay. Now run it. Oh, no, it works. So 50 alerts, or 49 alerts were sent to iAlert, and as you can see, without intelligent alert grouping, there were actually 49 alerts created. So some of them are VPN tunnel down, unavailable, ICM ping unavailable, Microsoft SQL Server is unavailable. So literally 49 alerts. Let's resolve them all, and let's try this again. Let's go back to the alert source and enable intelligent alert grouping again. And I told you about this threshold, right? It's set to 0.05, 0.75, And we make it very easy by showing you a preview of what the effect of your threshold will be on existing past 30 alerts, 30 days. So let's keep it at 0.75. And let's just make sure that all alerts are resolved. So we have 0 alerts. And now let's run the same runner that creates these 49 alerts via Postman. It worked. Now let's go back just to see the results. As you can see, we don't have 49 alerts, we have instead 7 alerts. So all of these alerts that were related to each other, they were intelligently grouped. Let's, for example, look into one, the VPN tunnel down alert. And we can see here that this one has actually grouped 17 alerts. And that's how it works. Like I said, these were instances of real alert flooding, and instead of having 50 alerts in a short period of time, we only had 7 or 9, and they were all related to different things. Okay, thank you. If you would like to learn more about other AI use cases for incident management, feel free to grab a copy of our incident management guides and AI.